after we do this one. All right, so when you get something like this, pay close attention because there could be a nice bonus on this. You basically want to take whatever is there, You hear me say whatever is there, correct? Because it could be more than just n sometimes. And you grab whatever is on this side. You have to remember whatever is on this side is always what we consider our n, and whatever is on that side is what we consider our r. And the best way to think of permutation is from n number of options, we pick a certain number, right? So if you have 5 people and you want to pick 2 people at a time, you go 5 pick 2. We're going to solve for n here. So what we do is we know that this would be n factorial over n minus r factorial. And that whole thing is supposed to be 42 for us here. This is the formula for permutation, and that's what you're given, right? So whatever ends up being here, in this case it is just n, right? We're going to plug that in here and in here. Okay? And whatever is in for r, in this case 2, we're going to plug that in there. So let's go ahead and do that. N is that's just itself, so we're just going to plug in n factorial over, again, whatever is in for the pink comes back here, minus r. R in this case is 2. And we slap a factorial on that. And that whole thing is supposed to be equal to 42. And this you should recognize. Something like this, like, oh, this is just a normal equation, right? But I'm going to go ahead and I'm just going to highlight, right, that I insert whatever was in the pink over there. And here it is one more time. Okay, so now it's basically like before. At the top, n has to be greater than or equal to 0. In the denominator, n has to be greater than or equal to dos, right? 2. There you go. So that's my overall restriction. Let's keep going here. So I know that the top is the bigger expression, so it's n times n minus 1 times n minus 2. I stop it there because I have the n minus 2 at the bottom as well, factorial, and that is supposed to be equal to 42. Here you just cancel those out. I will show my cleaned up version here. In this case, I would FOIL out like this. So it's n squared minus n. I bring the 42 over to the left-hand side and it changes the sign. So you will often see, it's like, oh, I've seen this before. You'll think you've seen it before, but sometimes the sign is different, which kind of changes your answer as well. Okay, so you got to watch out for that. So once you have that, you can use a quadratic formula, you can factor, you can do whatever you must do, right? So I will use my quadratic formula. So n is equal to negative b plus or minus, this calls for b as well, which is negative 1 squared, minus 4 times a times c over 2 times a. This is the one instance that I wish we would do a bit more factoring in grade 11 applied, just like the basic factoring, but it just takes a little longer. It's not a big deal. And I'm assuming you have the formula for the quadratic formula on your study sheet, or you use your calculator to graph it. It's up to you. This would then give me, cleaning this up would give me positive 1 plus or minus. You plug this into your calculator. You want to do it? I sometimes see that you're so close, but you get the wrong answer there. So I use brackets every time. Don't forget the sign of b is negative, right? It's right there. Negative n. So b is negative. Minus 4 times 1 times negative 42. You should get 169 over 2. And this is where you branch off into your two solutions, right? If this is ever 0 inside, what does that mean? You remember? There's only one root. If inside, this is called a discriminant, remember? Not really, but hey, if this is 0, you're going to get the same answer twice, which means there's only one answer, okay, so if that ever happens. So n1 is going to be 1 plus root 169 over 2, and second option is going to be 1 minus 169 over 2. You grab your calculator, 1 plus root of 169. Oh, it's 13 divided by 2. Don't forget that. That's 7. And then I copy paste that expression and I just insert a minus there. That's negative 12. You already know it's not going to work. You divide that by 2, it's negative 6. Right? So this is our answer. N is equal to 7 is our answer. And you could plug it in and check to make sure. How would you check? I would go way to the original. It says NP2 is equal to 42. So you go 7, P2 is supposed to be 42. Now you can type this into your calculator. But what does 7 pick 2 mean? It also means this, right? 7 times 6 is equal to 42. Remember? 7 pick 2, the pattern is you start with 7, then with 6, because you're only going 2 spots. So 42 is equal to 42. Check, right? It's up to you. Now, while you were writing your AC, I wanted you to have some more examples. So if you want more of this type, write this down at the bottom of this page. If you want to practice for the test or whatever, some are harder, so don't go for the crazy ones, right? Go for something like this or whatever you've seen on your ACs. That's what I would expect you to know how to do. So page 256, 15 to 16, equations with perms, right? It's kind of like what you just saw here. Yeah. And if you just want the good old equations without perms, 259, question 7 has a few there. So if you want to practice, I know I don't use the textbook a whole lot, but I hope you know that the answers are at the back, because I haven't been using it a whole lot. So I have a sticky note for myself. I go all the way to the back. Right now, this is like chapter 3. But if you just keep flipping through it, it kind of gives you a hint, right? Like what page you're on. So I would go, keep going. So here you're 259. We were in the 259s, right? We were there. So actually, now I have to go back a section, and it's probably somewhere in here. Okay, you just have to follow the question number, and then you'll find it. Or 255, that would be section just before. Okay, so keep that in mind. Their answers are there. Put a sticky note on it. Okay, let's continue. Pathways. That's what we're going to be parking on today. Formulas, make sure your formulas are on your study sheet. Okay. Pathways, you cannot miss it. You'll recognize it a mile away. Okay. When asked how many different pathways from point A to point B, it is a permutation question dealing with identical objects. So it's kind of related to what we've done before. We kind of divide out the identicals. Movements to the side or east or west are considered identical. Movements up or down, north or south, are also considered identical. There are two methods you can use to solve pathways. Okay. This is probably going to be the quickest way of doing it. I would really want you to know how to do it both ways, but the number of pathways, you go total blocks traveled factorial divided by the number of horizontal blocks factorial times the number of vertical blocks factorial. Okay, and note, I will have to give you a note here. This formula may have to be used several times if you have stops along the way. If you're stopping or going through a point, you may have to use that formula again. Okay. And so the second method is counting method. Just look at my examples, right? So this method number 1, method number 2. Okay. You want to highlight those, maybe different color, method 1, method 2, formula or counting. So for example, you have something like this, only a direct route. There's a direct route from A to B. How many ways can you go from A to B, assuming we travel north-south, and so from north to south, so you're always going this way, always, and west to east. You're traveling, so your options are going down or going to the right. That's all you have here. Use both methods. Now, if you use the counting method, I go like this. Okay, so I go down to get to this point. There's only one option here. Okay, to get to this point, there's only one option as well. See that you go this way or this way. So if you want to know how many options there are to get to this point, you add them up. Watch what I'm going to do. I'm going to go boom, boom. So I go 2. Okay, there's 2 ways to get to this point from A at this point. So you continue that pattern. Okay, so this would be 1. There's also just 1 here. There's also just 1 there. There's only one way to get there. So this keeps on adding up. 2 plus 1 is 3. There'd be 3 ways to get to this point. 3 plus 1 is 4. There'd be 4 ways to get to this point right here. So as you can tell, we're trying to add up how many ways there are as we go along. Similarly, if you go down to this point right here, there's also just one way to get to this point. So you basically just copy this one down. You'll notice that that's the pattern. 1 plus 2, there are 3 ways to get to this point. 3 plus 3, there's 6 ways to get to this point. 6 plus 4, there are 10 ways to get to this point. And now you know that to go from A to B, there are 10 different ways to get there based on using the counting method. So this is counting. Okay? And this is formula. So pathways, you basically have to count the total number of steps you would have to take to go from A to B, just like this. Watch. You count how many there are horizontally. There's 3, and then there's another 2 going down. So there's 5 blocks 5 factorial ways to get there, okay? And I'm going to highlight that in yellow. And you might ask, Mr. Anderson, could I have gone south, like 1, 2, 1, 2, right? Like 2 and another 3 is 5? Yes. It's up to you how you want to go there, but you basically count the total number of steps it would take you to go from one to the other. And in the denominator, you go, how many horizontal blocks did you travel? So to go from here to here, you traveled 3 blocks horizontally. And that's where the 3 factorial will come in. Okay. And you traveled, how many blocks did you travel vertically to go from A to B? And that is 2. Okay, so that's where the 2 factorial comes in. You should never get a decimal here. If you do get a decimal, you got to go back. You miscount it. Okay. So all we have to do is figure out what 5 factorial is, and that's 120. What's 3 factorial? 3 factorial is 6. 6 times 2 is 12. 120 divided by 12, 10 ways. Okay. Does it, and you want that to match, right? Like quite often you'll be able to do both and verify, okay, I'm doing things right. Okay. I'll do it a little, I won't be explaining every step of the way here. So by the way, it says how many ways are there to go from A to B. So to go from here, you start here. Assuming we can only travel south to north, so you can only go up, and east to west. So east to west, we're going this way. If you ever, these are the only 2 paths you can take. So you can basically go this way and up. That's the only way, right? Why that is saying is you can't just start traveling and all of a sudden be like, oh, I'm going to go up and then back this way. You can't do that. That would mess up our system. Okay, it's only one way. Okay. So I'm going to do formula first. So paths, let's do that first because then we can verify that we counted correctly. So you grab, it's up to you if you want to do the highlighting. I don't blame you if you don't. But it's 1, 2, 3, 4, 5, 6, 7. Right? So 7 factorial is going to be your top number. That's the total number of steps taken. Now I need to get my horizontal and my vertical. It doesn't really matter which order you do them in, okay? But you go horizontal is 1, 2, 3, 4. So I'm going to put a number down here. And vertical, I have 3. 1, 2, 3. That'll go here. So we've got 4 factorial, 3 factorial. 7 factorial. I need help with that one. Is it 720? What? Why are you looking at me, Mr. Dirksen? I don't know. Right. Okay, 5040. Okay. 6 factorial is 720. 5040 over 4 factorial. Either you remember that it is 24, right? So it's 24 times 3 factorial if you want. So it's 144. Drum roll, I hope this is not a decimal. Phew, 35. There are 35 ways according to my formula. Let's verify that. So I'll tell you this, some students, I'll tell you the trick, they don't like once I show them this way, they want to keep it that way. They don't like to go the other way. So you can just do this and then you're fine, right? So I'll go 1, 1. In fact, watch this. It's gonna be whatever number, like if this is 1, you just copy it all along. There's only one way sideways to get there. Like you're not gonna take a turn and go a different way, right? It's only one. Same thing here. Okay. Sorry, I said students don't like it upside down. It's me. I don't like it upside down. So I just do this. Okay. Don't blame the students, right? So basically just copy down this one. There's no other way, right? You can't take any turns. You're just going straight down. So there we go. This would be 2, 3, 4, 5. And then this is 1 and 2 is 3. 3 and 3 is 6. 6 and 4 is 10. Don't rush too much, right? That's 15. 4, right? 1 and 3 is 4. 4 and 6 is 10. 10 and 10 is 20. 20 and 15, 35. Does it match our formula? Yes, it does. Not right now. What's happening here, right? But it is. There's nothing wrong with this. Doing this, flip it, sure. And 35 means 35, so we're doing good. You can say, put a note like Mr. Dixon, flip the page. That's why it's upside down, or I don't know, whatever you want to do. So this is the basic. There's just going from A to B. There's no bottleneck, what I call a bottleneck. Okay. Let's keep going. What if there's a bottleneck here? Look at it now. So you're going through a middle point. So this is the second case, middle point. Only one bottleneck. Basically, you need to break this down into, you're going to go from A to B, and then you're going to go B to C. Okay, that's what's happening here. So again, A to B and B to C. So using the formula, and in math stands for multiplication, right? So you're going to have to multiply everything you get here times everything you get over there. It's almost like two questions in one, right? We're going to multiply them. So let's do the counting again. So I'll do my total from A to B. So how many boxes would it be? 1, 2, 3, 4, right? That's 4 factorial. What would I divide that by? 2 and 2, right? It's 2 going this way, and it's 2 going horizontally. So we just go 2 factorial, 2 factorial. I don't know. Do whatever, like, it doesn't really matter, right? It's 2 and 2, so whichever highlighter you give it, you won't be wrong. Okay. So this is one bracket. Then the next bracket is from B to C. How many total here? So you go from B to C, just start walking. 1, 2, 3, 4, 5, 6. So 6 boxes total. It'll be 6 factorial. How many horizontal from B to C? It's 4 this way. So you go 4 factorial. And how many vertical? It's 2. So we do it that way. And now I'm going to highlight everything. So 6 for the total. 4 is my horizontal. So I'm just going to make sure I keep that in mind. 1, 2, 3, 4. And 2 is my vertical. There we go. And now you just need to clean that up. Okay. Use your calculators if you have to, but I know 4 factorial is 24. 2 times 2 is just 4. Multiply that by 6 factorial, that's 720 according to my, I'm just going to double check. Unlike Dory, I don't remember anything, even if you told me 5 seconds ago, right? So 720, this is 24 times 2, that's 48. Usually, you know what, it's up to you what you want to do here. You want to go this times this, over this times that, or clean it up even further. 24 divided by 4 is 6. 720 divided by 48. Oops, you can see that. That's 15 exactly. So that would be 90, sorry, 90 ways. I'm expecting my answer to be 90. How would I do that using the counting method? We're going from A to B. So ultimately you want to know from A to C how many paths are there. Okay, that's your ultimate goal. So we start the same way. 1, 1, 1, 1. Then it's 2, 3, 3, 6. What happens there? I had 6 ways to get to this point right there. You transfer that over. So it's still 6 to go from there. It's still 6 ways to get there, 6 ways to get there. It doesn't matter because you're going straight. Then this would also go 6, and this would also go. So you copy down whatever number you had here. You just copy that along the sides like that. Okay. Then it's 6 and 6 is 12. 6 and 12 is 18. 24. 30. So it'd be 30 ways to get to this point right there. Keep going. 12 and 6 is 18. 18 and 18, 36. 36 and 24, 60. And 60 and 30, that's 90. You choose what method you want to use, right? I'm just showing you that either way works. I would tend to go with the formula most of the time to save me some time here. Okay, I want you to try. I'm going to ask you to try the bottom one there on your own because I want to do the next one here. I'll just tell you what the answer is, and I'll post the key though. Don't worry. 4,200 ways is your answer for the next question. So this is homework. Guess what? You're going to go, watch this, you're going to go from A to B, B to C, right? And then C to D. So there's like and. You're going to have to multiply this answer, by that answer. Okay? You notice that we start at the bottom, right? So if you don't like that, flip it upside down and then you're good to go. I don't think there would be a difference, no. Yeah. That's true. That's probably the best way to do it. Right? Let me think about it. If that could throw you off on the exam, if they ever did that, if there's a way that could throw you off, I'll think about it. For now, I'd say maybe flip the page for now, just to be safe. Okay, going through a middle point. But there's multiple options. I want you to highlight the or part. Or is plus. So pay attention to this one. You can tell that there's two options, right? I can go for, if I want to go A to B, then I can go through C or I can go through D. So this is how you break it down. A to C and C to B. That's one way of doing it. Or I could go A to D and from D to B. Those are your options. The or, you know it's going to be plus. All the ands, you know you're going to have a multiplication happening there. Okay. So, pay attention here. If you're considering A to C, you want to do this. Okay. You're just considering those boxes because you can't go past it because it doesn't allow you to go back up, right? We're only traveling either down and sideways one way. You can't go all over the place. It would mess up our system. So A to C, let's see if we can do this without highlighting. From A to C would be what? 2, 4, right? 4 ways. 4 ways total. Divided by, there's 2 horizontal and 2 vertical, right? I'll explain tomorrow a bit more why we do the division. For now, you just have to trust me. And C to B. So what you need to do there is like consider that the boxes that are there. How many total? 4, correct? 4 boxes over 2 horizontal, 2 vertical. So it's just 2. It's the same in this case. Or we're going to have to add our answers. So let's reset. If you're going from A to D, you're going to do this. Right? That's all you have, A to D. How many boxes in total? You go 1 plus 3, that's 4. 4 factorial over 1 horizontal and 3 vertical. And you still need to keep going to get to your final destination, which is B. If you're going from D to B, that's what you have left. So you travel 4 boxes over 3 horizontal, 1 vertical. Okay. How is this going to clean up? I'll just give you this is 24 divided by 4, which is 6. So we're going to go 6 times, this is 24 divided by 4, which is 6 as well, plus 24 divided by 6 is 4. 24 divided by 6 is 4 as well. That's 36 plus 16. There's 52 ways. I'm going to not do the counting today. And I want you to try this one as well for homework. Okay? I don't care if you get it wrong right now. I need you to just try it. If you get it wrong because you maybe plugged in the wrong number, so be it. But make sure you try this. So the 33 and 34 as well as 35. I will post 35 has more. Okay, like that. So I will say 33 to 35 is your homework. Okay. This still has to do with repetition. That's why we're dividing out. I'll show you tomorrow.